All right, let's get started here. So we finish up. We finish chapter 7. Sorry, chapter 8.1 here. Non-right triangles. The law of sines is the first one we're going to do. So at this point, the Pythagorean theorem doesn't work anymore. You have to find the sides using law of sine. We're going to have 4 different cases. Chapter 8, it's all about solving triangles. So finding all the angles, finding all the sides. But depending on what you're given, you'll use 2 different methods, either law of sines or law of cosines. Well, law of cosines will be 8.2. So let's do the first one. So here's the big picture. It's kind of like a formula. The trigonometric functions can also be used to solve oblique triangles using the law of sines. Okay, so here's your formula. It's going to be for an ABC triangle. So in an ABC okay. So given the triangle that I'm going to draw in a moment, given this triangle, oops. Our angle A, B, C are over here. Opposite to those main angles are going to be the little lowercase a, B, and C. So very similar to how we've been setting it up. It's just that we no longer have a right angle, okay? Which means you can't do Pythagorean theorem, so don't try. So given that triangle, the following is true. Sine of capital A over lowercase a is equal to sine of capital B over little b, which is also equal to sine of C over little c. So all 3 of these are equal to each other. So depending on what you're given, you can choose one of them, set equal to the other, and solve for A, B, or whatever. That's what we're going to start doing. Okay. So I recommend using this one, number 1. And you can use this for anything. That is case 1 and case 2, which I'll write down in a second. But my advice is use this if you are solving for an angle. It will save you like 1 step. And then use this one if you're solving for a side. It's the same thing, it's just if I take the reciprocal of every single one, they're still equal. Okay, just flip them over. Yeah. To use this if you are solving for a side. Okay. So if you start out this way, it'll be a little bit easier, but it doesn't matter which one you choose technically. Okay, so here are the four cases. Case one, one side and two angles, ASA or SAA. So basically, if you're given, if the question is giving you two angles in a single side, then we have case one. Okay, and then the book calls it angle side angle or side angle angle. Because if you have two, you can solve for the third, right? Really easily. Because those rules still apply. Sum of 180 for all angles is still true. Case two. You're given two sides and the angle, I'm sorry, yeah, and the angle opposite to one of those sides. Side angle, angle. So if you have those two cases, then use law of sines. If you don't have these cases, you cannot use law of sine. Okay. We're not going to do case three and case four today, but I'm going to write them down anyway for next time. Case three, you have two sides and an angle not opposite to either of those sides. Case four is all you have is sides. Side, side, side. Okay. If you have case four, case three, this would be a law of cosine problem. Okay. But again, we'll focus on those case three, case four tomorrow or Friday. Let's start an example. Just a moment. You guys cool on this page? Let me give you an extra note here. Law of sign problems sometimes has, I guess, let me phrase that better. Will have one, two, or no triangles as a solution. So when you're solving them, it's possible you end up with an error. So there is no triangle. Okay, so when you're trying to solve it, that could happen. Now, I'll show you a picture in a second. I think I have it here somewhere. Okay. Let me share this so it appears in the video. This is the book, the PDF. So these are the three tasks we wrote down already. So let me find the multiple triangle issue. Here we go. So we're gonna run into this in a second. So when you're using log sign to find one of the three sides or one of the three angles, it's possible you have a triangle that doesn't close off. So the side is not long enough. So when you're trying to do kind of push stuff into your calculator, you can't find it. The other scenario is the right triangle. We've done many of those. Two triangles is the weird one. So you know when you do sine and inverse, you get two possible solutions, right? That happened last example. So those two solutions will create two possible triangles. So either it swings out this way, so let's suppose solve for gamma here. You sine inverse both sides and get two angles. Angle one, angle two. So angle one works, and angle two works. That means that the side comes to flip out. And if it flips outward, then you have a different length anywhere close to them. Yeah, you have two different triangles. These sides are fixed, right? The B is the same as the one of the other parts. So when you're solving, you'll have two triangles, but certain parts will be the same in both triangles. And of course, the solution will be this. Okay. Just want you to see the reasons and why it happens. So the first one we're going to do where is my PDF? It's just a one triangle problem. But before we do that, if you have, or if you are given, it's better. If you are given two angles then you only have one triangle. So you don't have to worry about checking or, because it kind of already exists. So if you have two angles, then the other one has to be a specific angle, right? Because it has to sum up to 180. So you're not going to use sine inverse. When you use sine inverse, that's when the possibility happens. Okay. So the question one, example one. Solve this type. Angle, angle, side. So this is a picture from the book. This is all I'm given. Okay. So the way what I recommend is write down everything you have. I don't have little a. Well, actually, I do. Opposite capital A is 10. Opposite, I don't have any other side, so I have two angles and one side. So because I have two angles, I don't have to check or worry about the two triangles issue. So step one, let's go ahead and find B. You agree that B is simply 180 degrees minus A minus C, which is 180 minus 50 minus 30. Right? So we got B. So I'm gonna box in the ones that we have found. That way I know what was given and what wasn't. Oops, I smeared it. Okay. So now I need to find those two sides. So that's what we're going to use the number 2 formula for law of sines. We'll find, I guess, lowercase b first for no reason. So start it up like this. Set the b part equal to any of the three parts, right? The formula said this is equal to all three. So choose the one that you have, like the actual parts that were given. We were given a and little a, right? So we should set it equal to that one. So set this guy equal to A over sine A. That makes sense why I chose it? Because these are given. Solve for B. In order to solve for B, you would multiply both sides by sine B. So B is simply equal to A sine B over sine A. So just plug it in. That's it. So this whole chapter, you're going to need a scientific calculator or graphing, either one. So A is 10, sine of B, which is 100. We found that earlier, over sine A, sine of 50. I don't know what that is. Make sure your calculator's in degrees. Then plug it in. Yeah, we're good. If you have one of the newer calculators, you can force a triangle by, or sorry, a fraction, pressing alpha y equals, or you could use parentheses. If you don't have a newer calculator, you would put parentheses for the top, right? Divided by the bottom. Either way, if you have an older calculator, just make sure top, everything on top, parentheses, divided by everything on the bottom. If you do that, it will never mess up. Okay. So little b is approximately, I didn't say how much to round to, so let's just pick whatever. 12.856, I guess. Well, you know what? Let's do 1 decimal place. That's too much to write. 12.9. It doesn't matter. You can put whatever you want, but I think this looks slightly prettier. Okay, so we found little b. Now all we need is little c. Okay. To do the same thing, just repeat it. I don't know if I have enough space, but we'll try it. So set this guy, c over sine c, equal to the same thing. A over sine A. Solve for c in the same way, and you'll end up with c equal to A sine c over sine A, which is 10 sine 30 over sine 50. Whatever that is your last answer here. I skipped some steps because I'm out of space, but we do the same thing. We do sine B over B, we do sine C times sine C, right? The algebra there. So that'll be about 6.5. Yeah. Any questions about any of the steps? We're using the law of sines to find the pieces that we're missing. Okay. Okay, so let's do one that could have a second triangle, so we gotta check. Okay. Then once we verify that we do, then we're gonna have to solve both. If we verify that we don't, then we're good and just repeat this type of work. Just do one triangle. Are you guys cool on this page? So let me know. This is example 3 in this book, but we're changing the order because this one's a little easier. Example 2 is like, I feel like the difficulty is kind of spikes. So you know what, we should go with 3 and then 2. A little more chill. Okay, so A is something. We don't know what A is. We don't know what B is. C is supposed to be 85 degrees. Little a is not given. Little b is 9. Little c is 12. Okay, so we're missing 2 angles. So when you're solving for it, you need to find out, okay, I need a test. Do I have 2 triangles or not? And if not, then I'll just won't worry about it. Okay. Once you find one angle, though, you can find the other by subtracting from 180. Finding this side will require law of sines. So let's see. You see that I have to start with capital B. Do you see why? I can't mess with this. Because if I try to, I'd have 2 unknowns, right? So you'd have sine A over A, which means you can't do anything. You can only have one unknown in one equation. So I'd have to start here, because then I'd have a missing B, but I could solve for B and have everything else. So I'm going to purposely solve for step 1. Solve for capital B. That is the only thing you can do at this point. You have to start there. Does everyone see why I have to start at capital B? All right. So let me know. So then since I'm finding an angle, set this equal to the stuff that has both of them. Sine C over little c will be the one we choose. So solve for B, that would be multiply both sides by little b. Isolate that sign. So now I end up here, sine capital B equal to B sine C over little c. Sine inverse of both sides would get us to here. So capital B is equal to sine, well, you know what, I don't have space there. Capital B is equal to sine inverse of B sine C over C. Yeah, so I'm solving in general before I plug it in. Is the algebra okay? Do you still have to get here? But then the side numbers of both sides. Tell you if you're there, in order to cancel the side. They mean B. But B is whatever the numbers. Plug it in.
Where did you get it?
So you can always do the inverse of both sides whenever you want. Just like remember on test 2, we had to solve for the angle. It's the same thing. We're solving for that angle. Okay. Then once you do that, you remember we had a possibility of 2 different solutions. So that's what's going to happen again. So B would be equal to sine inverse of 9 sine 85 over 12. I don't know what that is. Sine inverse of 9 sine 85. So 48. So this is approximately 48.3 degrees. Stick with 1 decimal. So what we're going to do, I think the book calls it B prime. So B is 48.3. B prime is 180 minus that answer. Remember how that's what we found it in the last test, we would subtract. So that's about 131.7. So we have 2 possible solutions for B. If both of them work, then that means you have 2 triangles. So we need to check, okay, are they both solutions or not? And if they're not, then we'll just do 1 triangle. It'll be easy. If they both work, then life sucks, and we got to do two triangles. And I don't like it. But that's how it goes. Yeah. When you have case 1 and case 2. Oh, well, hold on. Like, you mean this step here? Whenever you want to solve for an angle, I needed that capital B. The only way to cancel the sign is to do inverse. Yes. So anytime you're not given 2 angles and you have, I guess let me look at the cases here. Go back to the beginning. So if you are given 2 sides, so basically case 2, whenever you have case 2, you could have 1, 2, or no triangles. Case 1 will always guarantee 1 triangle because you have 2 angles. Basically, try my third point. You find the third, which means that a triangle exists. Here we don't have any. We have 2 sides of an angle, so we're going to look at both of them before. Hold on, twice. It never goes off. That weirdness happens with this one.
And the lowercase are sides, right?
Lowercase would be size. The book uses alpha, beta, gamma. I'm using capital letters, lowercase letters. Doesn't matter.
Have 2 lowercase, that's in triangle.
Yeah, if you don't, yes. As long as it's case 2, then you could have 1, 2, or none. If it's case 1, you will have 1 triangle. Okay, so case two is the one we don't know. So let me show you how to test. So case two, this nonsense happens. So this is how you test. So step two. Verify that B plus C is less than 180. And B prime plus C is also less than 180. If one of them is above 180, then that means it's not a solution. So you will only have one triangle. Okay.
Which is the 48.
Yeah, this will be 48 plus 85, right? So let's try it out. So B plus C is equal to 48.3 plus 85. Is that less than 180 degrees? That would be what? So we're good, right? Very cool. So that one is a solution. Now let's check the other one. That would be 131.7 plus 85. Is that less than 180? That's 216, right? So this right here, this tells us that we have only one triangle. So if they both would have been below 180, that would tell you have two triangles. Okay, and that's the worst case scenario. And if you're solving and you get an error during this step, that means you have no triangles. Okay. That's the best case scenario because you can stop right away. So when you're trying to solve one of the angles, you get an error. So you know what? I guess there is no triangle. Anyway, does that make sense? The logic? So at this point, you just treat it like example one to solve the triangle. So we will assume that capital B is 48.3.
For instance, like that, we came out to the solution, but we just put it 0.
Well, like if you got an error on your calculator right here, you would just say, just stop and say there is no triangle. There's no solution. Yes, cool on example 3. I know it's technically the second example. It's example 3 from the book. All right, start the real example 2 then. Oh, wait, hold on. We didn't find 2 pieces, I forgot. Step 3. Since you have two angles, solve for A. Capital A. A will equal 180 minus 85 minus the angle you found, 48.3. That is 46.7 degrees. So there's capital A. Step 4. Solve for capital A. Or, I'm sorry, lowercase a. So choose the one that is good for sides. So I'm looking for lowercase a. So start with that piece. Set it equal to the one that had both to begin with, the side and the opposite angle. Or opposite angles, angle opposite side. So isolate A. And you will end up with C sine A over sine C. And multiplying both sides by sine C. I skipped that step. Or sorry, sine A. Is that cool? You see how we got from here to here? All right, then just plug everything in. Little c was 12. Sine of A was 48.3. C was 85. So that solution will be the missing side. What's up? Oh, was it? Probably right. Pushing 0.7 today, right?
Would it be the other way around? Yeah. A sine C.
Here?
Mhm.
Let me see. We can multiply both sides by sine A, so this should be up top. See?
Oh,
So yeah, it would be this part's good. The angle was wrong. Should be 46.7. Okay. Double check everything. 85. Yeah. So what is that? Eight point eight.
but why is it A sine A? It's C of the sine versus it's A of the sine of the B.
You can choose either one, any of them. All three are equal to each other. So choose the one that you have. So the strategy behind it, when you start. I need to make sure everyone understands that all three are equal. So start with the one you're trying to solve. Set it equal to one of these two, but choose the one that actually has given solutions or given given parts in the problem, right? So if we go back to that question, we were given the C's. So I set equal to those two parts. So that makes sense. That's how you choose. But the work will be the same over and over again. Just make sure you know how to choose. Okay. But anyway, that's all the answers for A. and little a. Any other questions? Is it okay? I'm just gonna write them in then over here. The answers were, I wrote them down here. 46.7. Little a was 8.8. And the rest were given.
Question,
Mhm.
verify that it's only when you're solving. It's an angle, right?
Yeah, whenever you find an angle, so if you're missing two angles, you have to do sine inverse to find one. And when you do that, you have two possible angles you gotta verify. Yeah. But the next one with same thing, except I think both will work. Solve the triangle. So all chapter 8 is solve the triangle. Side angle. In this question, they gave us a equal to 35. Little a equal to 6. Little b is 8. And that's all we got. Since I know this will be two triangles, I want to make space here for later. Okay. The given parts will be the fixed parts. Where? Okay. So we're gonna try to find capital B. And then we're gonna have to test the two possible B's, and it's gonna turn out that they both work. Step 1. Solve for capital B. So let's start with this guy, sine capital B over little b, set that equal to the A's, right? Choosing the A's because I have them. Okay. So isolate sine B, multiply both sides by B. We get you to here. Solve for capital B, that would be a sine inverse thing. So that means that B is equal to sine inverse of B sine A over little a. To plug it all in, this would be 8. I forgot the sine inverse. So sine inverse of 8 sine 35 over 6. Plug that into your machine and you should get, earlier I got 49.9. Okay. So since B is 49.9, that means that B prime will be 180 minus that, which will be approximately 130.1. But we still got to test, even though I know they work. Let's test to see. Step 2. Verify how many triangles you have. To do the same thing. So is A plus B less than 180? And is A plus B prime, is that also less than 180? Plug in A, you'll have 35 plus 49. Over here, you'll have the same thing, 35 plus the 130. So we're gonna get, what is that, 35 plus 49? $84.9. So yes. 35 plus that would be 165.1. This right here tells us, right, this part, both are less than 80. We're gonna have two times. Okay. Sorry, I'm running out of time, so. So at this point, you're gonna use both angles. So go ahead and write it in here. So solve for C and C prime, just by subtracting from 180, and you'll have those parts. So the only thing actually you have to do is find C and little c prime. Okay. Do that on the next page. In a second. Yeah. Yeah. And both are yes. One, if there's only one, then you have Okay, so step 3 will be just simply find capital C and C prime. So C will simply be 180 minus A minus B, which is equal to 180 minus 35 minus 49.9. C prime will be the same thing, just use the other ones. Minus A and B prime. That'll be 180 minus 35 minus 130.1. So you can find both right away. So this will be 95.1. This will be 14.9. That makes sense?
That or that was.
Yeah. Capital C's. So find the little c's using law of signs twice. Be the last step. You guys cool on that page? Step 4. Find little c and C prime. The size. So C over sine A, I'm sorry, sine C equal to A sine A would imply that C is equal to A sine C over sine A. Plug all that nonsense in and we'll have C. So 6 sine 95.1 over sine of 35. Then do it again for C prime. So basically, it'll be the same formula just with primes. Six sine 14.9 over sine of 35. This side will be approximately 2.7. Let me take roll. We'll call it here. Marginal. All right, Sadie.
Here.
Jadlyn. Ava, Andre, Zoe, Aaron, Michael, Alexandra, Juan. No, Juan, sorry. Juliana, Epifania, Andrea, Kimberly, Diego, Teresa, Hunter, Angelica, Connor. All right, guys, we'll finish this one up next time and then we'll start 8.2. This one won't be due till Sunday.